I want to look at combining logs. If you have multiple terms that are log terms, it's important that we know how to combine them, because this is going to be one of the key steps when we start trying to solve equations with logs in them. So what do I mean by that? I mean, oftentimes we're going to have log terms that we're either adding or subtracting. So for instance, let me just give you an example, and then we'll talk about how we're going to combine these. I have log base 3 of x plus log base 3 of 5y. Now we're going to talk about in a little bit, later on in this class, how to solve equations with logs in them. And one of the things we're going to have to do is we're going to have to be able to combine log terms. So this expression has two terms. Remember, terms are separated by addition or subtraction. So there are two terms here, and I want to combine them somehow into one log. And we're going to talk about the rules that allow us to combine those. So let me give you the two main rules that we start with. The first rule is when you're adding two log terms. So if you have log base A of u plus log base A of v. A couple key things. One of the key things is, first, we're adding two log terms, and the second key is both logs have the same base. This rule only applies when you're adding logs with the same base. So here it's log base A, log base A. And what this rule simply says is, when you're adding two log terms together, you can write it as one log term, and you simply multiply the u and the v. We can call these the arguments, the stuff inside the log. There are also times when you want to subtract log terms. So in this case, now we're subtracting two log terms with the same base. And what's interesting is, once again, if we're subtracting two log terms with the same base, we can combine those into one log. And now it becomes log base A of u divided by v. So when you're adding log terms, you multiply the arguments. When you subtract a log term, you take the first argument divided by the thing you're subtracting. Whoops, I made it. I'm glad I saw that. Should be a v here. And now there's one more rule. Let me go ahead and show it to you, and we're going to use it in a little bit. And this is where, when you have coefficients in your log terms. A coefficient means it's a number in front of the log, a number multiplied by the log. So for instance, in a little bit, we want to solve problems like this. 5 log base 6 of x plus 2 log base 6 of y. You notice I'm adding two log terms, and they have the same base, but now I have coefficients in front of my log terms. The first log term has a coefficient of 5, and the second log term has a coefficient of 2. There's a special rule. The thing is, what I want to point out is, if I go back to my first two rules, when I'm adding these log terms together or subtracting them, you notice there's no coefficients in front of the logs. I cannot apply these rules if there's numbers in front of the logs. So somehow, to apply the addition rule or the subtraction rule, I have to make sure there's no numbers or no coefficients in front of the logs. And there's a fancy way we can do that, and here it is. So here's an example of a log base A of x and the coefficient c. So c is in front. C times log base A of x. Here's the third rule that's very useful. When you have a coefficient from your log, You know what you can do, which is interesting? You can take the coefficient and you can actually move it and it will become the exponent of the argument in the log. So the coefficient, the number in front of the log, I can move it and it now becomes the exponent inside the log. Very interesting. So these are the three rules, first rule, second rule, third rule, that we're going to now use to start combining multiple log terms into one log. So start with a few straightforward examples and then maybe do a few more difficult ones. Matter of fact, I'll do the example I wrote at the beginning, log base 3 of x plus log base 3 of 5y. I'm adding two logs, there's no coefficients, they have the same base. So what am I going to do? I'm going to put log base 3, I'm going to multiply x times 5y. I'll just call that 5xy. How about this? Log base 9 of 2z minus log base 9 of x. So once again, two log terms. They have the same base. I'm subtracting, so I can combine them into one log. Log base 9. Now I take the first argument, the 2z, and I divide it by the argument of the second log. So it becomes log base 9 of 27 over x. And it's pretty much that simple. Now let's combine that with this whole idea of coefficients and see what we're going to do. Because in this case, let's look at this one. 5 log base 2 of x minus 2 log base 2 of y minus 3 log base 2 of w plus 10 log base 2 of z. I have now 4 log terms that I want to combine into one log. Now, they all have the same base. The base of all the logs is 2, but you notice they all have coefficients. My rules about adding and subtracting log terms only apply if there's no coefficients. So the first step is, for each of these log terms, I have to, quote unquote, get rid of the coefficients. And that's where I'm going to use my third rule, where I can take the coefficient and move it up and make it like an exponent. So let's go ahead and do that. For each of these terms, I'm going to move the coefficient and make it an exponent inside the log. So this first one would be log base 2 of x to the 5th. So I move the coefficient up into the exponent. For the second one, the 2 is going to get moved minus log base 2 of y squared minus log base 2 of w cubed plus log base 2 of z to the 10th. All right, so now my 4 log terms, now there are no coefficients. Now I can apply my rules about adding and subtracting log terms. So it looks like the second and third one are being subtracted and this fourth one's being added. So I'm going to have, when I'm all finished, looks like x to the 5th in the numerator, and then the y squared is going to go on the bottom, and the w cubed is going to go in the denominator, and then the z to the 10th is going to go back in the numerator. And now I've combined those into one log. Now let's talk about one more twist. Sometimes your coefficient, in this previous example, the coefficients were all nice sort of integers, but that's not always the case. For example, you might have a log like this, 1/3 log base 4 of w. and I want to go ahead and get rid of that coefficient, well, of course, I can apply the rule and move that 1/3 to make it an exponent inside the log. However, math etiquette, they don't really like you to leave. Remember, these are called rational exponents. They don't like you to leave that as a rational exponent. Now we have to do some quick reviewing. If you remember when we studied rational exponents, we can always convert them into radicals. Remember what we would do? The denominator becomes the root or the index of our radical, and the numerator ends up being the exponent. So really, if you recall, w to the 1/3 is really the cube root of w. And that's what they like the answer to look like. They like it to be in the radical form. So it's a log base 4 of the cube root of w. So now, having realized that, now let's look at a problem like this. And let's use natural log just to keep in the practice of using natural logs also. 3 natural log y plus 1/2 natural log of w minus 5 natural log of x. So 3 log terms. I'm adding and then subtracting 1. They all have coefficients. I want to combine those into 1 log. First step is get rid of the coefficients. So I say, well, natural log of y cubed plus, now this is going to be natural log of w to the 1/2. Let's think about that for a minute. Let's save some time. What is w to the 1/2 going to be as a radical? W to the 1/2 is the square root of w. So this is going to be natural log of square root of w minus natural log of x to the 5th. So now I can combine these into 1 log. Natural log in my numerator is going to be y cubed times the square root of w, and then in the denominator is going to be x to the 5th. So once again, I've taken those 3 logs and combined them into 1 log. Let's do one more problem. Don't know if this is hard or easy, I just wrote it down. We'll see. Log of x cubed y squared. Here, log is base 10, right? Common log, and there's no base there. We know it's a base 10. Minus 2 log x cube root of y minus 3 log of xy. Now actually, I have 3 terms here. I've got a couple of coefficients. They'll have the same base for the logs. But this problem began out with a radical. In this case, I need to convert the radical into a rational exponent to be able to solve this. So I'm going to have to take a minute and rewrite because what this is going to be is log of x, and then the cube root of y is just y to the 1/3 minus 3 log of xy. And now I need to get rid of the coefficients. The second and third terms have coefficients. So let's see what happens here. Log of x cubed y squared minus log of xy to the 1/3. I put that whole argument in parentheses, and it's going to get squared, so the coefficient of 2 becomes the exponent, minus log of x over y, and that whole thing is also cubed. Now I'm going to go ahead and get rid of these parentheses. And let me just do it for these last two. So I can rewrite the first term, and it's okay. So here, power rule, if I distribute that 2, I get log of x squared. Y to the 1/3 raised to the second power is y to the 2/3 minus log of x cubed over y cubed. So now let's go ahead and combine these into one log. So my first argument goes in the numerator, x cubed y squared. The second one, since I'm subtracting, that goes in the denominator, x squared y to the 2/3. And this last one also goes in the denominator. Wow, this looks messy. Now I need to do some simplifying, so I have x's and y's in here, so let me figure out what's going on. Let's see what we have here. First of all, if I look at the x's, I have x cubed in the numerator and x squared and x cubed in the denominator. By the time I try and cancel stuff out, it looks like I'm going to be left with x squared in the denominator. Now the y's are even more complicated. You notice this y cubed down here? The little shortcut is when you have the denominator of a fraction in the denominator, that eventually goes to the top. So this y cubed comes to the top. So what I have really is y squared times y cubed over y to the 2/3, which is really y to the 5th over y to the 2/3. And if I use the quotient rule, 5 minus 2/3, that's 15/3 minus 2/3. I believe that's 13/3. If I didn't make any math errors, I believe that's y to the 13/3. And now I'm going to go ahead and leave that as a rational exponent. Maybe in the book they would want to convert that back to a radical, but that's going to be so ugly that I think it's okay for now. And the key is just to get the principle of how to combine multiple log terms into one log. Not too difficult as long as you follow the rules and do things in the proper order.